Hello friends, welcome to my channel. So here we are going to discuss the next activity. Now let us start the next activity. Do an activity to show that the rise of temperature depends on nature of the substance, or show with an activity that rate of rise in temperature depends on the nature of the substance. So for this activity we need hot water at 80 degrees Celsius, water at room temperature, and oil at room temperature. Coming to the procedure, first take a large jar with hot water. Sorry, take a large jar with water and heat it up to 80 degree Celsius. So first we are taking the jar and we are taking some water and heating to a temperature of 80 degree Celsius. Take two identical boiling test tubes with single hole cocks. So we are taking two test tubes having single closed cocks. One of them is filled with 50 gram of water and the other is filled with 50 gram of oil, both at room temperature. So fill one with oil and one with water, which are at room temperature. Next, two thermometers insert two thermometers through holes of the cocks, each one into two test tubes. So here in the single hole rubber stoppers we are placing two thermometers. Okay, so one in oil and the other in water. Next, clamp them to a retort stand and place them in a jar of hot water. So with the help of retort stand we are placing both the test tubes in hot water. For every 3 minutes note the reading of the thermometer. So we have given some same amount of heat to water and oil, because they are kept in the jar of hot water for the same interval of time. So as we kept in the same hot water, they will receive equal amount of heat energy. That means equal amount of heat is supplied to both the test tubes. And we observe that the rate of rise in temperature of oil is higher than the rate of rise of temperature in water. So if you observe here, initially both are at same temperature. Both this one and this thermometer will show same reading. But as even though we supply same amount of heat energy for these two test tubes, the rate of rise in oil, or the reading of thermometer which is kept in oil rises faster when compared to water. So why? So from this we can conclude that the rate of rise in temperature depends on nature of the substance. So it depends on the nature of the substance. That is activity 5. Moving to the Snell's law activity. How do you find, or how do you verify experimentally that sin I by sin r is a constant? Or the question can be asked as, explain the relation between angle of incidence and angle of refraction with an experiment. Or write an experimental procedure to obtain relation between angle of incidence and angle of refraction. Coming to the activity, our aim is to obtain a relation between angle of incidence and angle of refraction. For this we required a protractor circle, scale, small black painted plank, a semicircular glass disc of thickness nearly 2 cm, pencil and laser light. So these are the material required for conducting the activity. So first take a wooden plank which is covered with white chart. Take a wooden plank and cover it with white chart. Next, draw two perpendicular lines passing through middle of the paper as shown in the figure. So you can see here. So first place a paper on the wooden sheet and draw two perpendicular lines passing through middle of the paper. So one is vertical line, the other is horizontal line. So here this is the point of intersection. We observe in this figure. So and let this horizontal line be mm and vertical line be n. Let the point of intersection be O. So we have the point of intersection of two lines here. So let this point of intersection be O. Mark one line as NN, which is normal to the another line marked as MM. So you can see here the horizontal line is MM, the vertical line is NN. Here MM represents the line drawn along the interface of two media and NN represents the normal drawn to the line at O. Now place a semicircular glass disc so that its diameter coincides with interface line. So now take a semicircular glass slab and place it on the in a such way that its diameter coincides with the line mm and its center coincides with point O. Point a laser light along NN in such a way that light propagates from air to glass through the interface at point O and observe the path of laser light coming from the other side. So if you observe here, first incident light along the normal. So along the normal, and you can see that the light ray is coming out in a straight line. So we know that when the light ray is incident on normal, there will be no refraction. Next, coming to the seventh point, send laser light along a line which makes 15-degree with NN. So from here, from this NN vertical, from this vertical line, draw a line at an angle 15-degree and incident the light on this line and measure its corresponding angle of refraction. So find the corresponding angle of refraction on the other side. Now note these values in the table and do the same for angles of incidence such as 20, 30, 40, 50 and 60 etc. So now repeat the experiment with different angles of incidence such as 20, 30, 40 and note down the values in this table. So what are the tables we are taking? Angle I, angular, sin I, sin R and sin I by sin R. So find sin I and sin R for every I and R. So for every angle of incidence and for every angle of refraction, find the sin value. And finally, we get sin I by sin R is a constant and this ratio is called refractive index. Coming to the next activity, how do you verify experimentally that angle of refraction is more than angle of incidence when light ray travels from denser medium to rarer medium? So now we are going to prove that when the light rays travel from denser to rarer, angle R is greater than angle I. So to prove angle R is greater than I and when light rays travel from denser to rarer, it bends away from the normal. For this we required metal disc, protractor, two straws and water. First we'll take a protractor circle and arrange two straws at the center of the pro circle in such a way that they can be rotated freely about the center of the pro circle. So we have to arrange two straws at the center of the pro circle such that they can easily rotate. Adjust one of the straws at an angle 10 degrees. So fix one of the straw at an angle 10 degree. Immerse half of the portion or half of the pro circle vertically into the water filled with a transparent vessel. So fill a transparent vessel with water and immerse half of the pro circle in water, and you can observe here remaining half of the pro circle is in air. So while dipping, verify that straw at 10 degree must be inside the water. So straw at 10 degree must be inside the water. from the top of the vessel, try to view the straw which is inside the water as shown in the figure. Then the other straw, adjust the other straw which is outside the water until both straws look like they are in a single straight line. So you must place the second straw in such a way that the straw which is inside the water should be in straight line with the straw which is outside of the water. Then take pro circle out of the water and observe the two straws, and we'll find that they are not in a single straight line. Measure the angle between normal and the second straw and record the values in the following table. Do the same for various angles up to 48 degree and find the corresponding angles of refraction, and note down angle of incidence here and corresponding angle of refraction for every angle of incidence. From the table and above activity, we can say that R is greater than I in all cases, and the light ray bends away from the normal when it travels from denser to rarer.